Sec 4 AMF lesson 18 additional practice. Okay, question 1. Find the coordinates of D. Now, if you look at the coordinate D, right, it is the y-intercept of the line AD. Okay. Now, alternatively, what we can do is we can let the coordinate of D be 0, y. Okay, and then we find the gradient of AD. Okay. Now, if you realize, right, the gradient of AD, when it's multiplied with the gradient of AB, you'll get -1. Okay, so let's go and find the gradient of AD. So before that, you can let the coordinate of D be 0, P. The letter, I'll leave it up to you. You can choose any letter you want. So the gradient of AD. To find the gradient of AD, first you're going to find the gradient of AB. Okay, so the gradient of AB is -1/3. So -1/3 times the gradient of AD should give you -1. So the gradient of AD will therefore be 3. Okay, now we can create an equation for AD and find the y-intercept. That's fine. Or what you can do is you can go and find the gradient in terms of P. Because just now we let the coordinate of D be 0, P, right? So the gradient of AD, let's go and find it in terms of P. So it's 8 minus P over 2 minus 0. So from here, you get 8 minus P over 2 equals to 3. So 8 minus P equals to 6. Therefore, P equals to 2. So since P equals to 2, the coordinate of D is 0, 2. Okay, part B. Find the coordinates of C. Okay, now if you look at the coordinates of C, right, and where it's located at, okay, it is actually the intersection of MC and BC. Let's highlight it quickly. Yeah, it's the intersection point of MC and BC. So we have the equation of BC, right? So all you have to do is just find the equation of MC, do the simultaneous equation, you'll be able to solve for the coordinate of C, okay? Okay, so let's go and find the equation of MC. So when you go and find the equation of MC, right, we already have the gradient. The gradient of MC is the same gradient as AD, okay? So the gradient of AD is 3, right? So the gradient of MC is also 3. Okay, next, what is the coordinate of M? So according to the question, M is the midpoint of AB, right? So we can find the coordinate of M by finding the midpoint of AB, okay? Right. Okay, so we established that the gradient is 3. So coordinates of M is the midpoint of AB. So add the X coordinate divided by 2, add the Y coordinate and divide by 2 as well, you get 5, 7. So now we have the gradient, you have a coordinate on the line, throw it inside the y equals to mx plus c. You'll get your y-intercept, which is -8. Therefore, the equation of the line MC is y equals to 3x minus 8. So let that be equation 1, and equation 2 will be 3y minus 4x equals to -14. Okay? So we can use substitution. So hold on. Okay. So you can use substitution. You just take equation 1 and slot it into equation 2. You get the following. You'll be able to find for x. So 5x equals to 10, x equals to 2. Take x equals to 2 and throw it into equation 1. You get -2. So the coordinates of C is 2, -2. Okay, part C. Find the area of ABCD. So when you're finding an area in AMF, right, just use the shoelace method straight away, okay? So write it in this format, okay? If you start with 2, 8, and you end with 2, 8, okay? Okay. So do the shoelace method. So it goes this way, right? 2 times 2, which is 4. Yeah, 2 times 2, which is 4. 0 times -2, which is 0. 2 times 6 is 12. And 8 times 8 is 64. Then you go in the opposite direction. 0 times 8, 2 times 2, 8 times -2, and 2 times 6. So therefore, you get 40 units square. Okay. Question 2, circles. So we have a circle 1 which passes through the points 1, 2 and 5, -2, and the center of the circle lies on the following line. Okay. Now the points given to you, right? 1, 2, and 5, -2, right? They are just random points on the circle. Okay. So for questions like this, right? Okay, you might want to do a rough sketch over here. And just plot your points here. 1, 2 might be here. Let's go x1, y2, somewhere here, right? And 5 -2 might be somewhere here. Okay. So here's your P and here's your Q. Okay, so when I connect these two lines, right, do not assume that there's a diameter straight away. Okay, it's not the case. So there's 2 points here. Okay, then next we have a line y equals to -1/3 x plus 2, which passes through the center of the circle. Okay, so if this following line which passes through the center of the circle. So I just write it for you. All right. Okay. So the rule states that the perpendicular bisector of any 2 points on the circle will definitely pass through the center of the circle. Okay. So in part A, they want you to find the equation of the perpendicular bisector of PQ, right? So perpendicular bisector. Bisector means it cuts right in the middle. Okay. And perpendicular, as you know, right? So what you want to do is you want to find the gradient of PQ, right? Okay. Okay, so here they start off in the midpoint, it's fine. So you just find the midpoint, add the x coordinate, divide by 2, add the y coordinate, divide by 2, you get 3, 0. Okay, so that's the midpoint of PQ. Next, go and find the gradient of the perpendicular bisector. So before you find the gradient of the perpendicular bisector, okay, find the gradient of PQ first. So the gradient of PQ is -1. If the gradient of PQ is -1, the gradient of its perpendicular bisector will therefore be 1. Okay, so create an equation. Okay, so this thing is going to overlap what I just drew. Right? Just give me a moment. Try and shift as much as I can. Okay. Okay. To throw the 3, 0 and the gradient 1 into the following equation, you'll get y equals to x minus 3. So the perpendicular bisector will be y equals to x minus 3. All right, so I'm going to just draw it for you. So the perpendicular bisector here will cut. Okay, so it's not drawn to scale, so I'm just purposely going to draw it the way it cuts the center of the circle. Okay. All right. So this red line here is your y equals to x minus 3. Okay. The perpendicular bisector will always pass through the center of the circle. Next, in the question itself, it says that there's another equation, y equals to -1/3 x plus 2, which passes through the center of the circle. If two lines passes through the center of the circle, and if these two lines intersect, it means the intersection point is also the center of the circle. So all you have to do is just do the simultaneous equation of the perpendicular bisector and the line given to you over here. Okay. So do the simultaneous equation. As I mentioned, you'll be able to find the center of the circle. So I'll just show you straight away. So the coordinates of the center of the circle is 3 whole 3/4 and 3/4. Now this is just your center of the circle, okay? So now you have to find the radius. So the definition of radius is from the center of the circle to any point on the circumference, which means from this coordinate over here, 3 whole 3/4 and 3/4, right? Connected to either P or Q, you will be able to find the radius, okay? So in this case, they decide to go with coordinate P, which is 1, 2. So use the formula that you learned in EMAF. You get square root 9 whole 1/8. Now take note for this topic, right? Do not give your radius in 3SF or decimals, okay? You all have learned certs already, so leave it in certs. Okay? So the radius is the radius of the circle is 9 whole 1/8. So what's the equation of the circle? Sorry, I repeat again. The radius of the circle is square root 9 whole 1/8. So the equation of the circle will be, you just take the center of the circle and throw inside the equation. And this part here has to be r squared, so the square root goes off. So this is your final answer. Part C, find the equation of the second circle C2, which shares the same center as C1 that has an area that is 4 times that of the circle. Now take note, this is something that you learn in Sec 2, okay? If the ratio of the area is 1:4, then the ratio of its length is the square root, okay? So you can write it in this format, A2 over A1 equals to R2 over R1 bracket square. Okay. So which means the area of the new circle C2, right, is 4 times the area of C1. So you can write it in that format. So the radius R2 over R1. So work your way around to find R2, make it the subject. So when you transfer the power, it becomes square root 4, which is 2. So therefore, your radius for the second circle will be 2 square root 9 whole 1/8. So this is how you write your equation for the circle. Same center, just the radius is different. So it'll be 36.5 when you square it, okay? So technically, if the area is 4 times, then the length is twice, right? So the radius, you just multiply by 2 before you square again, okay? Okay, question 3. Given that cosine x equals to -5/13 and tangent x is less than 0. Okay, so what you want to do is quickly draw your quadrants and label it as A, S, T, and C. Okay, so how I like to see this is A means all, sine, S means sine, right? So they're like the kings of their respective quadrants, okay? In other words, in that particular quadrant, only sine of the angle is positive. The third quadrant, only tangent of those angles in that quadrant will be positive. And the last one, only cosine of the angle in that quadrant will be positive. So this is 0 to 90. This is 90 to 180. The 180 to 270 and 270 to 360, okay? Now for cosine x to be negative, it means it cannot be in this quadrant. It cannot be in this quadrant because all sine, tangent, cosine will be positive here. Here cosine will be positive. So the places where cosine will be negative are at sine and tangent. So these two quadrants, you can cancel it off straight away. Next one, they said tangent less than 0, right? So it means it's either in quadrant 2 or quadrant 4. So if you look at both criteria, right, quadrant 2 appears on both. Therefore, we select quadrant 2 only, which means the quadrant that has sign. Okay? Okay, in case if you're confused, what tangent x less than 0 means, right? Numbers less than 0 means negative. So in other words, that is saying if tangent x is a negative. Okay, that's all. Okay, so we established that it will be the second quadrant. So what you want to do is draw a triangle like this, okay? Once you draw a triangle like this, right? Cosine x is 5 over 13 with a negative sign. Okay, so cosine is adjacent over hypo. Now, right, you can treat this quadrant like a graph paper, like an axis on a graph paper, okay? So on a graph paper, besides positive, positive, right? Positive, negative, 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 and negative, positive here, right? So if there's -5 on the x coordinates, on x coordinate over here, it will be -5, right? So just write down -5 here. Now hypotenuse can never be negative, so just put positive 13 here. So -5 over 13. When you do a cosine angle over here, it'll be -5 over 13. So use Pythagoras theorem to quickly find out what this value is at the side over here. We'll get 12, okay? So before you write 12, treat it like axis on a graph paper and check. Will the 12 over there be a positive value or a negative value? Now, it's definitely a positive value because it looks like it's measuring up the y-axis, right? And it's above the x-axis. So therefore, the 12 there has to be positive. So once you establish the numbers, which is negative, which is positive, right? Everything becomes easy. So what is sine x? Just read it off. It is opposite over hypo. Positive 12 over positive 13. Done. Okay, next one for part B, right? Use your formula sheet. Okay, so your formula sheet will say cosine 2x equals to 2 cosine square x minus 1. So cosine x is already established as -5 over 13. So replace your cosine x with -5 over 13, then put the square. You put the -1, you get minus 119 over 169. Okay, part C. Sine x over 2. Okay, now over here, right, use the formula sheet again. So cosine x equals to 1 over 2 sine square x over 2. Okay, so now what you want to do is rewrite it in such a way that sine x over 2 is the subject. Okay, so shift it over. So 1 minus cosine x, divide by 2 and square it. Okay, the plus minus. Okay, so for quadrant 2, sine x over 2 equals to 1 minus cosine x over 2 with a square root, positive square root. Okay, so replace your cosine x with -5 over 13. Key this in your calculator, you get 0.832. Okay, question 4. Now, question 4, right, uses the R formula. So just apply the R formula straight away. Okay, so to find R, just key in the values inside, you get square root 13. Then to find your alpha, tangent inverse 3 over 2 will be 56.3099. So apply the formula, you get 2 sine x minus 3 cosine x equals to the following over here. Okay, so for part B, right, we will use the R formula. Okay, so we will not use this equation. We rewrote this equation this way, right? We'll use this instead. Okay, so whenever 2 sine x minus 3 cosine x can be rewritten as square root 13 sine bracket the following angle inside equals to 1. Okay, so now you're supposed to solve this. Okay, so you treat the x minus 56.3099 as an angle by itself. Now, if you treat this as an angle by itself, right, which means we have to change the range over here. Okay, so we're going to find the base angle first. So the base angle being x minus 56.3099 will be just written as alpha first. Alpha is the base angle, okay? So sine inverse 1 over square root 13 will be 16.102. Okay, so that is the base angle. Now we're going to change the range. So you change the range, make sure in the middle will be x minus 56.3099. So this is a new range. So once you have a new range, right, look at your quadrants, okay? Now, your base angle is positive, right? When you take sine of that angle, you get positive. Okay, wait. So when we take sine of the angle, you get a positive value here, 1 over square root 13, right? Okay, the 1 over square root 13 is a positive number. So where will you get the positive number? In the first quadrant and in the second quadrant. They're all on the sine quadrant. So it has to be in quadrant 1 or quadrant 2. Okay, so what I would do is I would draw a triangle like that, and I'll draw a triangle like that. Now we will start by reading this in the anti-clockwise direction. So your first angle will definitely be the x minus 56.3099 will be 16.2. Now your second angle, right, will be from here all the way till it stops at the hypotenuse. So it stops at the hypotenuse means from here to here, right? So it's just 180 minus the 16.102. So these are two angles here. Okay, so you might want to calculate what's 180 minus 16.102 first. Then after you go and find what's x, where you shift the minus 56.3099 over to both angles. So this will be a final answer. Round this off to 1 decimal place. Take note, only for angles is 1 dp, not 3 SF. So 72.4 and 220.2. Okay, question 5. So this is proving question. So you have to use your formula sheet as and when necessary. Okay. So you're going to prove, right? You're going to take the left-hand side and work your way through till you get the right-hand side. Okay. So this is how it goes. So you got secant x minus cosine x over 1 plus sine x as the left-hand side. Okay, so right now your LHS is the following. Now your secant x can be immediately written as 1 over cosine x. Okay, once it's written like this, right, try and make it into one singular fraction. So you just cross multiply. Okay. Now when you cross multiply like this, what happens is your numerator is 1 plus sine x minus cosine square x. Rearrange it like this. Okay, you just write the 1 minus cosine x beside here. So 1 minus cosine square x can be written as sine square x, because sine square x plus cosine square x gives you 1, right? So therefore 1 minus cosine square x is actually sine square x. Okay. Now from here, I think you all can see it already. You just have to factorize the sine x out from the numerator. You get the following. So you can cancel the sine x plus 1 and the sine x plus 1 top and bottom, leaving you with sine x over cosine x. Sine x over cosine x is basically tangent x, which equals to the right-hand side. Proven. Okay. Now if you compare part B with part A, the only change is x became 3x, right? Okay, and they use the word hence, which means this whole equation will now equals not tangent x, but tangent 3x. Okay. So the whole term on the left, right, will become tangent 3x straight away, goes to minus 1. So go and find your base angle first. So when you finding a base angle, the -130 is a positive number. Okay. So your alpha will be 45. The base angle, take note, it's actually 3x there, okay? Now, since we're dealing with 3x, your range talks for x only, right? So change the range to 3x. So it's 0 to 540. So which means 3x equals to 180 minus 45, 360 minus 45, and 360 plus 180 minus 45. Okay. Why the third one is a bit weird is because your range hits up all the way till 540. Okay. So when you're drawing for the quadrant, this is your ASTC, right? So when you go one full circle, it's 360. Then 360 degrees. Then plus another 180, reaching up to 540. Okay. So now your tangent 3x gives you a negative value, right? So this is A. This is S. This is T. And this is C. So it gives you negative, it can't fall here. It has to fall in the sine quadrant or the cosine quadrant. So for the range from 0 to 360 is quite easy. Just take 180 minus 45. So let's draw a triangle for you straight away. Okay, so remember I told you the angle must stop at the hypotenuse, right? So it has to start hypotenuse, so it's 180 minus 45 and 360 minus 45. So that is this two. So this one over here, now if I go another round is 540, right? But I have to stop at the hypotenuse again. So 540 minus 45. So this whole part here, the 360 plus 180, right? You just immediately write this down as 540 minus 45. Understand? Why? Because when you go one full circle, I'll show you one full circle, 360. Then 360, you stop till here. So the best way to calculate it is 540 minus 45. So 3x equals to the three different angles. I divide by 3, 845, 105, and 165. Okay. All right. So with that, we end the lesson today. Okay. I'll see you on the next one. Take care. Bye.